Hi everyone, welcome to talk session. In this session we will learn when to give self loop to any state in automata. To understand this concept, let's take few examples. First example, design DFA that accept all strings of A's including epsilon over sigma A. Here over sigma A it means what? All these strings should contain only one symbol A. Then identify the condition from the question. Condition is that DFA should accept all strings of A's plus epsilon. Based on this condition, write down minimum length string. Minimum length strings are nothing but set of valid strings that DFA should accept. First minimum length string will be epsilon as per the condition given, as length of the epsilon is 0 as its empty string. So first minimum length string is epsilon. Then all strings of A's, then second minimum length string will be A. Then I can write double A as there is a all string condition. I can also write triple A. Similarly, there will be multiple A's. Once we have written minimum length string, try to design DFA. As we know, automata consists of various states and states are represented by circle. This is our starting state. Remember in TOC, whenever epsilon is a part of minimum length string, our starting state becomes final state. Because conceptually if we say epsilon is nothing but the empty string. Empty string means nothing, no input. Hence, when automata enters without having any input symbol, automata is going into final state. Without any input symbol, automata is reaching to final state. Hence, whenever epsilon is a part of minimum length string, our starting state becomes final state. Next valid string is A. Hence, it should get accepted by DFA. That is, after reading this A, automata should enter into final state. Then only we can say A is accepted. But in this case, this transition is going to final state, but already we have one final state. So this transition can come back to the same state. There are two possibilities. Transition of A should enter into final state, either this or this. As per the definition of deterministic, we need to have only one transition for one symbol. Then we need to decide one transition out of these two. How to decide it? Let's understand one simple trick. Write down the string for which you are looking transition A. At which state you are looking? At which state you are looking? Q0. So write down Q0. Ask yourself whether Q0 is looking transition for single A or there is a possibility of double A also. As per the minimum length string set, there is a possibility of double A also. There is a possibility of 3 A's also. It means what? Q0 is looking transition not only for one A but also looking for multiple A's. In these multiple A's, Q0 is also have transition for 0 number of A's. How? 0 number of A's means what? Empty string. Empty string represented by epsilon. So we can write here epsilon. Epsilon is nothing but empty string. It does not contain anything, means there are 0 number of A's. Now Q0 is having transition or Q0 is looking transition for one or multiple A's or 0 A's. It means what? This scenario indicates there is a situation of 0 or many A's. Now in TOC you have to follow one simple trick. Whenever you will see scenario like 0 or many, maybe for A or B or any other symbol, whenever we have 0 or many scenario, we have to give self loop to that state for that specific symbol. Here state is Q0, symbol is A, and remove other possibility. Either this self loop or this one, you can keep any of that. So in such scenarios, we can give the self loop. Let's understand one or two more examples to clear this concept. Next question is construct DFA that accept all strings of A's excluding epsilon over sigma A. Or same question can be asked, construct DFA that accept all strings having at least one A over sigma A. Again, whenever over sigma A, it means what? These strings should only contain only one symbol A. Identify the condition from the question. At this moment, let's take first statement. DFA should accept all strings, but epsilon is not there. Then try to write down minimum length string. As in the question itself it is mentioned epsilon should not be there. So we will not write any epsilon here. All strings of age, minimum length string will be, if epsilon is not there, then one length string will be A. All strings, then double A is also allowed. Triple A will also be considered, and similarly 4 A's will also be considered. Now, once we have written minimum length string, start designing DFA. As we know, automata works in different states, and states are represented by circle. This is our starting state denoted by Q0. As there is no epsilon here, so starting state will not become final state. First minimum length string A. As this is a valid string, this should get accepted by DFA. It means what? By reading A, automata should reach to final state. That's the meaning of valid string. By reading A, automata should reach out to final state. Now A is accepted by automata as automata reach out to final state. Then take the next string double A. Double A should get accepted. It means what? By reading double A, automata should reach out to final state. Let's write down this double A. Automata starts with the state Q0. Q0 reading the first A. Reach out to Q1. First A read by the Q0. Now Q1 has to read the second A. Now ask yourself whether Q1 is reading only one A, or is there any possibility of multiple A's? If we take the next example, triple A, if we write like this, first A is read by the Q0, then automata reach out to Q1, Q1 reading the second A, after this again A is coming. If we take this example, if we write down like this, first A read by the Q0, second A should be read by the Q1, but after this A, multiple A's are coming. Similarly, there will be multiple A's. As usual, first A will be read by the Q0, but remaining A's Q1 has to read. Or we can say example of only one A. If I write here only one A, first A will be read by the Q0. What about here? Nothing. Nothing means what? Epsilon. Nothing means what? Epsilon. It's an empty string. If I simply draw one line here for better understanding, here my state is what? Q1. Q1 is looking for transition for 1A, or I can say 2, 3 or 4 A's. Here epsilon is also present, means Q1 looking for 0 number of A's. Again, if you observe it clearly, Q1 is looking transition for 1 or many A's as well as 0 A's. So here scenario is 0 or many A. 0 or many A's. But at which state? State is Q1. So in TOC, whenever you face a scenario of 0 or many A's, simply give self loop to which state? Q1. In this case, it is a Q1. So simply give self loop to the state Q1 for symbol A. This Q1 is telling you Q1 is reading 0 or many A's. Conceptually, if suppose there is single A, Q0 reading single A, reaching to Q1. After this A, there is nothing, means I can say empty string epsilon. So Q1 is not reading anything. If I take here triple A, so Q0 reading the first A, second A will be read by the Q1 using this self loop. So after the first A, if A's are coming, that is also fine. If A's are not coming, that is also fine. Hence, we need to give self loop to the Q1. And this is our final answer to this question. Let's take one more example. Before moving to another example, try to understand this second statement. Construct DFA that accept all strings having at least one A. At least one A. I will give simple example. In any exam, if exam is of 100 marks, we need 35 marks to get pass. At least 35. At least 35 means what? If I get 36, that is also fine. If I get 37, that is also fine. It means at least 35. Similarly here, automata should accept strings having at least one A. We have at least one A. If 2 A's are coming, that is also fine. 3 A's are coming, that is also fine. Many more are coming, that is also fine. Hence, meaning of the first and second statement is same. Only difference is asking the question in different way. Hence, answer to both the statement is same. Let's take one more example to understand and clear this concept. Construct DFA that accept all strings having at least 2 A's over sigma A. Over sigma A means what? All the strings should only contain symbol A. Identify the condition from the question, at least 2 A's. Now try to write minimum length string based on the condition. As condition says at least 2 A's, it means what? Minimum length string should be 2 A's first. Then other than this, if more A's are coming, then we can write down that also. 3 A's are coming, that is also fine. 4 A's are coming, that is also fine. Accordingly, multiple A's are coming, it will also work. Our main condition is that string should contain at least 2 A's. After this, try to design automata. As we know, automata works in different states and states are represented by circle. This is starting state Q0. First minimum length string is AA. This is valid string. Hence, automata should accept this. It means by reading these 2 A's, automata should enter into final state. One state read one symbol at a time. So Q0 will be reading first A and will enter into another state Q1. Only single A should not get accept. That's why I am not writing this is the final state. This is the intermediate state, non-final state. But second A, Q1 will be reading the second A and this is a valid string. So second A should get accepted. So first A, second A, this transition should go into the final state because double A is a valid string. If automata gets started with the state Q0, Q0 reading the first A, entering into Q1, Q1 reading second A, going to Q2. So double A is accepted. After this, next valid string is triple A. Hence, it should get accepted by DFA. It means what? After reading this triple A, automata should go into final state. If I write down this triple A like this, first A will be read by Q0. Second way will be read by this Q1. Q1 will be reaching to then Q2 after reading the second A. This third A, Q2 has to read. It means what? As this is a valid string, if Q2 is reading the third A, it should enter into final state. But already we have the final state, so this transition can be like this. Hence, there are two possibilities for the third A. Out of this, we need to have only one possibility. How to select it? Let's start with the similar kind of trick. Write down the string 3 A's. Out of this, first A read by the Q0 reaching to Q1. Second A read by the Q1 reaching to Q2. Write down the string, write down the state Q2. Now ask yourself whether this Q2 is reading only one A or any other possibilities after this A. If you observe the minimum length string, there is a possibility of multiple A's. First A read by Q0, second A read by the Q1, third A Q2 has to read, but after this third A there is one more A is coming. If I take the another string 5 A's, similar kind of scenarios. First 2A read by Q0 and Q1, third A Q2 has to read, after that many A's are coming. In addition to this, if there are no A's are coming, what's the example of that? Example is double A. Write it like this. First A read by the Q0 reaching to Q1. Q1 reading the second A reaching out to Q2. So Q2 reading what? Nothing. Nothing means what? Epsilon. So Q2 reading epsilon. How many A's in the epsilon? Epsilon is an empty string. It contains 0 A's. So can I say Q2 is reading epsilon means 0 A's. Q2 is reading 1 A. So length of this string is 1. Q2 is reading what? May read 2 A's. Q2 may read 3 A's. Like this, there will be many more A's. Hence, can I say Q2 is reading 0 or many A's? So again, there is a similar kind of scenario. Hence, In TOC, whenever you will face scenario like 0 or many, any symbol A, B or 0, 1, 2, 3. Whenever there is a 0 or many, you have to give the self loop for that symbol at that state. So Q2 is a state. So at Q2 you need to give the self loop for that specific symbol. Hence another possibility of this can be removed. And this is your final answer to this question. All these three examples explain you how to write or when to write self loop. You can practice these questions which are similar to what we have seen. In the next session, we will see how to design DFA to accept even number of edges or odd number of edges. Thank you for watching.